Hey guys, welcome back to my BMAT advice series, where I give you guys my tips to doing well on BMAT Section 2. My name is Firaz, I'm a Cambridge student who scored an 8.6 in the BMAT Section 2. In this video, I'm going to tell you guys everything you need to know about BMAT Physics. So BMAT Physics consists of 7 questions in 7 minutes, but timing isn't really a major issue, because the questions are pretty straightforward in my opinion. The main issue I find as a BMAT tutor is that students are somewhat unfamiliar with the BMAT physics content because they don't do physics at A level. In terms of what the questions look like, around 3 or 4 of the questions are going to be calculation based, and the rest of the questions are essentially just knowing your physics from the BMAT Section 2 Assumed Knowledge Guide. Things like sound waves, electricity, etc, etc. So in terms of doing well in BMAT Physics, I have a couple tips for you guys. But before I say anything, I want to hammer away the tip that I always talk about, which is anytime you're doing any sort of calculation in the BMAT, work in fractions as much as possible because it's going to make it way easier and it's going to make your calculations a lot more accurate and quicker. So without further ado, my first tip for you guys is to use proportions when doing physics calculations. So a lot of the time with physics calculations, you don't need to actually crunch the numbers. If you simply use the proportion from whatever equation you have, you can figure out the answer without actually doing a single written calculation, and this can really help speed things up, and it allows you to save time that you can then spend on the much more difficult maths questions. So I'll give you guys a quick example. Boyle's law, which is P1V1 is equal to P2V2, simply means that the product of the pressure and volume is going to be constant. So therefore, if you double the pressure, the volume must half. And if you think about these relationships like this, you don't actually have to do a lot of the calculations. The same can be said about something like Hooke's law, or the equation for potential energy stored in a spring, or any of those types of equations. You can figure a lot out just by using proportions instead of actually doing the calculations. If you guys want to learn how to speed up your calculations in BMAT Section 2, as well as everything you need to know about exam technique in BMAT Section 1, how to write a Section 3 essay, as well as the BMAT 2022 Section 1 and Section 2 walkthroughs which we're adding to the course, check out sigmamed.co.uk. It's a £30 BMAT course that teaches you everything you need to know about doing well in the BMAT, and it's made by 2 Cambridge University medical students. It costs less than 1 hour of tuition, and I implore you guys to check it out if you're studying the BMAT this year. So my second tip for doing well in BMAT physics is really knowing electricity well. They seem to absolutely love this topic, so I'm going to teach you guys some of the basics. So first of all, why don't we start with the basic definitions. So charge is a physical quantity, and it can either be positive or negative, and it has the symbol Q. Current is then the rate of flow of charge with respect to time, and this therefore gives us the equation that I is equal to Q over T. So it's essentially how much charge is flowing past the point every second. Voltage is potential difference. You can kind of think about it as an electrical pumping power. And the way we quantify voltage is with the equation V is equal to IR. Another equation you might need is P is equal to IV, as well as the equation that E is equal to PT. This is more or less most of the electronic equations you're going to need for BMAT physics. And obviously you can combine equations, and sometimes in the BMAT you will have to. So just know how to do that, know how to rearrange these equations, and you should be fine. Knowing these definitions, we can then talk about series and parallel circuits. So in a series circuit, the current's going to be the same everywhere, and the voltages and resistances are going to add together. With a parallel circuit, it's a bit different. The current has several routes it can go down, so the current's going to split. The resistance follows the equation you can see up on screen, and the voltages are going to be equal in each branch. So the other thing I want to teach you guys is about transformers. So transformers look a bit like what I have up on screen. You have a primary coil and a secondary coil, and the role of transformers is to turn the mains alternating current into a direct current so you can use it in your homes. So you can have step up and step down transformers, and all this means is if the secondary coil has more turns than the primary coil, it's a step up transformer, and vice versa. And the equation we're working with here is V1 over N1 is equal to V2 over N2, i.e. between the primary and secondary coil, the ratio of voltage to number of turns is going to be constant. So therefore, if you increase the number of turns, you also increase the voltage, and that's why it's a step-up transformer. The other thing you just want to be aware of is the fact that you have an efficiency. So 100% efficient transformer means that the power, which is current times voltage, in the primary coil is going to be equal to the power in the secondary coil. Those are just 3 quick teaching points which cover the basics of electricity, and I think this is a really important topic, and in my opinion is the one that you should know the best for the BMAT, because it just comes up so much. They really like this topic. My third tip for doing well in BMAT Section 2 physics is knowing the physics based on its core principles and key terms. It makes it a lot easier to remember, and it avoids you making silly errors because you don't understand things properly. One example is, what is terminal velocity and how do forces relate to this? So terminal velocity is when an object's falling and it's as fast as it's ever going to go while it's falling. This means that there is no net force slash resultant force on the object, i.e. upthrust is equal to its downward weight. And acceleration due to gravity, as we know, is 10 meters per second squared. So the BMAT will often play with concepts like this, making sure you know what terminal velocity actually means, what a resultant force is, which is the overall force acting on an object once you've subtracted forces that are working in opposite directions. And you should just really have a good core understanding of the key terms so you don't make mistakes here. Related to this, just know the definitions of different parameters in physics. So for example, the fact that acceleration is the rate of change of velocity with respect to time. And from this, if you see a velocity time graph, its gradient is going to be acceleration. Knowing these things makes calculations a lot easier, it makes things easier to remember, and it avoids you making unnecessary errors in the BMAT. Now I'm going to take you guys over a quick example of a BMAT past paper physics question.
Lab bench is switched on when there are no radioactive samples in the lab. The count rate displayed by the detector is 24 counts per minute, so that's the background. A radioactive sample is now placed next to the detector and the count rate displayed is 248. So 248 minus 24 is equal to 224. So that's the radiation that the sample causes, that the sample is responsible for. The sample is left next out to the detector for 48 hours, after which time the count rate displayed is 31 counts per minute. What is the half-life of the sample? So if it's 31, that means that the sample is responsible for 7. So we want to find how many half-lives exist between 224 and 7 counts per minute, which come from the sample. So 224 divided by 2 is 112. 112 divided by 2 is 56. 56 divided by 2 is 28. 28 divided by 2 is 14. So that's going to be 1, 2, 3, 4, 5 half-lives. 5 HL in 48 hours. Therefore, HL is going to be 48 over 5, which is equal to 9 plus a bit. So let's look for the answer option that's a bit more than 9. That's going to be D, which is 9.6 hours. So that's how you do this type of question.
Thank you guys for watching the video. My next few videos are going to be BMAT Section 2 full paper walkthroughs, so make sure you're subscribed. Check out sigmamed.co.uk, and thank you for watching.